videos along the way today, and for those that have a QR reader, here's one. I don't know if anyone wants to take a poll. I know it's late in the day, so we're going to try to be as sort of interactive, engaging as we can, and we're going to talk a little bit about what we're doing in the area of mobile. We're going to talk a little bit about interactivity, what we're doing with Scenic on those two fronts, and then also our plans and vision for app sharing. Okay. So, as you all know, mobile is really global. An interesting statistic is that there's actually going to be more active cell phones this year than humans on the planet. And the data is just continuing to grow, and with coverage not quite to all the rural communities as we've been hearing about today, but really getting there. So with all the devices that not just your students but your community has, you and all of us need to be providing that access to those different devices. So just a quick look at the American mobility trends from the Pew Research Center. Smartphone ownership is at 56% across the U.S. An interesting thing to think about, though, is that it's really closer to 80% among the college-age students. So that is really our demographic for the full-time universities, and it's an interesting thing to think about. So 80% really are coming instrumented with these devices. 42% have tablets, and that's a number that is, I think that's up almost 10% from last year. So that area is growing, and it's not exactly replacing laptops immediately, but there are people who are predicting that, that's going that way. So that really is the background for why we think bring your own everything is the right way to go when approaching a mobile strategy. The concept is that students really have a relationship with that device. A lot of people have talked about that to some degree, but there's anecdotes of students who'll go back for their phone but not their wallet. They'll go, they'll sleep with the phone by their nightstand or by their bed and the nightstand, and they know how to use it. You don't have to train them. And so there's a lot of reasons why BYOE and is really just, that sort of concept really is going, to be the way of the future. So little history. We started out in 2009 thinking about how are we going to get the content that UCLA provides and get it mobile ready, and we came up with this concept that a distributed set of apps that leveraged a framework, which would be server-side, could feel to the user like one environment. And that's what we ended up implementing for our UCLA mobile solution, which we still depend on and use today. And but that's been around for a while now. So we've been thinking about what's next, and we have been working across the system probably about as collaboratively as a system as we get. And several of the other UCs took that framework and produced their own mobile suites of apps. And in discussions with Scenic, we started talking with them about, we'd like to broaden that collaboration. We'd like to work with, make that, the code is open source, and make that easy for any web developer sitting anywhere in the educational spectrum of, California and beyond, but primarily those of us work for California, want to share. And so we said, let's see if we could put, the MWF, that framework, into an environment that Scenic would host and be able to sort of leverage the concept of working together across the state. So, and then additionally, we're also sort of going to talk a little bit today about what's next for MWF, but that realm is really blending in the new trend of responsive into the idea of the framework, so that blended interface, and you'll see more about that with the concept we have for app sharing. But the idea is that there's not necessarily one way to always produce the functionality that you want to do, that you want to provide, whether it's responsive or whether it's sort of more app-like and high functionality. They can be blended in, and the idea for the user is that they just have what they need in their hands on their devices. A little bit of background for those that aren't familiar with what MWF is. MWF is stands for Mobile Web Framework, and the idea is that it was device agnostic. Any device with a browser could leverage the tools built with that framework. It's platform independent, so at least on our campus, we have a variety of tools. We have .NET, we have Java, we have PHP, we have the whole 9 yards. And so anything built in those could also leverage the framework. It's built so that it's really easy to use, and it's almost like really a presentation layer, and then easy to deploy, but that meant you really had to have a server to put it on. So what we're trying to do is get rid of that and provide a way for people to use it in the cloud so that it would take that sort of server-side sysadmin equation out of the equation. And so we've been doing a proof of concept with Scenic and working on a sort of a joint endeavor where the Scenic team provides the platform as a service and a UC team provides the software as a service. And we have launched our own instance of MWF in the Scenic sort of managed AWS cloud, and then Berkeley's came up just in January, and we'll do a third campus for our sort of proof of concept effort, and then hopefully move into more of a production pilot mode. And we're working on these processes between the two groups, and then we're hoping to expand the collaboration. So just a little bit about benefits. Most people already are aware of these, but the idea would be that a web developer sitting anywhere in the education spectrum could call up Scenic and say, you know, we're interested, or call up our team, whatever we put in front of this effort, which is likely some sort of web environment. But say, you know, I would like to try this, and can I have a test site, and so on. And then we just put that in place, and they can start working to provide a mobile experience for their web services that they already provide. And so this is just showing you kind of like at the only difference is that at the top you're seeing two different URLs, and the scenario there is that with the proof of concept we weren't ready to commit that we were 100% going to go forward with this infrastructure, so we are only working right now in the proof of concept with a campus that already has an MWF environment as a production. So we're just doing 50% of our traffic right now on the Scenic side. But now I'm going to talk a little bit about an additional tool that we are planning to put into this same mode, and it's really around interactivity. And I did a survey with about 3 other colleagues across the U.S. through an EDUCAUSE project effort, part of it used to be called FRI, but now it's called Leading Change, a week-long sort of seminar that they put on. And we did a survey of students to see what they thought about interactivity in the classroom, so whether it's clickers or some other method. And so just one of the results from that survey was that about 70%, 68-70%, really felt that it was an engaging thing to do these clicker endeavors. So I don't know if I have any poll takers. Anyone have a QR reader on their phone to do a little mini demo? You can stand up too if you need like a break from sitting all day. Or you can go to that URL above the image and just search Scenic. And there's a little poll I put in there, and we're going to go to at the end for results. I'm not seeing a lot of phones. Oh, Tom's doing it. Good. Anyone else? Anyone else? Takers? I see a few more phones coming out. Somehow doing these activities, it's definitely groupthink. You got to get one, and maybe someone else will do it, and someone else will do it. So it's a quick survey that people can do. I'll give people another minute.
They're just doing it on their computers.
It's easier to do it on the thing. It might be hard at the angle if you're at too much of an angle. Give people a moment. Maybe you're at the wrong angle, Tom. I don't know. I don't know about closer, but I think it has to see it straight on, somewhat straight on.
Or you can just use that little tiny URL in the corner, ucla.in/1f, whatever that is.
Yeah, or you could just go to the other one. Everybody say, tell me if it works. I tested it, so I think it works with at least one of the apps. I know. I was Just want to let people who are trying to do it give it one more go. Did it go? You got it? Okay. All right. Yeah. That depends on your QR reader. Everybody get it that wanted it? All right, moving along. Are you good, Tom? Okay. So interactive polls, people are pretty familiar with this, but the idea is really allowing people to create the polls, collect the data, view the results in classroom, whether or at a lecture or at some sort of sort of talk that's something that you're working with an audience. And we're going to show you the results of the poll later on. But basically, that is another service we're hoping to be able to share across the community. Okay, so what we are interested in is trying to explore further collaboration. And one of the ways we really hope that this is going to evolve is with standards and open technologies and with all the partners involved in Scenic. And now Eric is going to talk about what CASA is. And CASA stands for Community App Sharing Architecture. Okay.
Okay. Thank you.
Did we lose connection?
No, but the screen is doing weird things. Let's just reload it.
It may be that it dropped.
Where's the word? There it is. It's the resolution changed.
Oh, because of the video. Should work better when you.
All right, there we go. Okay, so I'm going to talk a little bit about the community app sharing architecture. So our users today have mobile expectations that far exceed anything we probably ever would have guessed that they would have, say, 7 years ago when the iPhone first came out. They're demanding more and more apps, and they want they want a plentiful selection. They want those apps to be relevant to the things that they're actually doing, and they want those apps to be robust. And so MWF that Rose mentioned, that's going to be provided hopefully in the near future as software as a service, as well as other frameworks that are out there that can be deployed in various different ways, they make it easy to get going. But the question still rests on how do we enable an ecosystem where those apps are easy to get to, and regardless of who they were designed by, they can be used by our users. Search is not the answer. The World Wide Web is vast and uncurated. And search has a very limited ability to pitch the sorts of apps that actually pitch apps that meet the capabilities of the devices in question and that are relevant to our users. For example, if I've got a device that doesn't have a camera on it, search has no way to know that that's the case, and so it may pitch me apps that still require a camera on my device. It also doesn't have any real conception of interoperability. So if I've got a tool provider that needs integration with the W3C's packaged web app standard or IMS's Learning Tools Interoperability Standard, search doesn't have a way to know that. And worldview is another issue. Different institutions represented here range from kindergarten through higher education and beyond. And so the content that we want to be pitching, the things that are acceptable are different in different use cases. Search can help you slightly, but it can't go all the way as far as worldview goes. But there is a model that already does this well, and that is that of native app stores. Be it Apple or Google, they're cultivating and curating their app stores to meet with the specifications of their devices and to provide the set of content that they find acceptable in their cases. On the web, though, we're not quite there yet. And I'm going to start by talking about a couple examples of things that have implemented web app stores to some extent. One of them is the mobile web framework. The mobile web framework lets you customize the apps that you want to have on your home screen. But ultimately, it still requires manual intervention for an administrator of a mobile web framework instance to go and say, okay, what apps do I want to put out? And they can put out their institutions, or they can go and they can talk to other institutions and put out theirs as well. So they can contact their peers, they can get their apps, but of course for the network folks in the room, you know that's 1/2 n and -1 total connections needed if you want to have global awareness at all institutions. Another very different approach is that of eduapps.org. Eduapps.org acts as an aggregator, a central repository for apps. But this also has a very big problem with it. It requires a homogeneous worldview and understanding of trust. So in the case of eduapps.org, it's all about learning tools interoperability, a standard produced by the IMS Global Learning Consortium. If you don't implement that standard, you can't go up there. And if you do want to use them, you have to trust their decisions about who they've put up. So taking a different approach, CASA looks at how do we model the real world and the real interactions that we have as we go to hunt down these apps. And so when I, as an administrator, would go and look for apps that my students might find useful, I might pick up the phone and call somebody at another UC or a Cal State or something like that and ask, what apps do you have? So I could go out there and I could discover apps. And in tandem, I might be nice and I might tell them what apps my faculty and my students have produced. And going a step further than that, we might say, well, what apps do you know about that you've learned about from other places? And for people who are following this, what I'm really talking about now is a peer-to-peer network, where each institution is a peer in a much broader system. And the internet is actually full of examples of very, very successful peer-to-peer networks. So as we look to create CASA, we don't have to start from scratch on this. Instead, we can turn and look at something like routing protocols. In external routing protocols, each peer is an autonomous system that makes local decisions that suit their business model, their users, who's paying them in most cases. But it's roughly the same concept we're talking about here. The only difference is instead of talking about which routes I'm willing to serve, I'm talking about which apps I've found that I'm willing to vouch for. It's just a different layer of the network stack. And in doing so, what we do is we enable the creation of small world networks in this sort of an app sharing architecture. Networks that have a distributed topology, where you're just worried about your local awareness, but yet you're gaining a global knowledge of the network. And we also end up, of course, then with tightly coupled subgraphs, affinity groups of various sorts, be it like a professional school system, or be it the university system, a kindergarten system, whatever. But tightly coupled subgraphs that are then connected in far fewer points by certain people who have relationships across those subgraphs. Now this is all kind of theoretical, so I'm going to dive a bit into what we're actually doing with CASA. So the first thing we've got to do is we've got to define the network. And in the implementation so far, each autonomous system is running something that we call an engine. The engine has several responsibilities. It queries apps from inbound peers, and it can share apps with outbound peers. These are configurable in asymmetric ways so that you can end up with like hub and spoke subgraph topologies, or any sort of other thing that you can come up with. People can just publish, people can just receive. There are all sorts of options there. So it's very, very flexible. In addition, we provide a set of automated operations that capture the same sorts of decisions that we would be making in the real world if we were talking to other people about what apps they might have. We have potentially a different conception of what we call something, like a subject area. We might call it a category. So CASA has built into it the concept of translation. Additionally, it's got the ability to filter. So you can, if you know that you only provide, your IDP only provides certain shibboleth attributes, then you can go ahead and set it up so that it will filter things out if it needs shibboleth attributes that you don't have, because that would just be a non-useful app anyways. And we can also transform. So for example, common named apps. Like if I receive a directory from UC San Diego or UC Berkeley, I don't want to call it the directory because I've already got an app in my store called the directory. But I can curate that and transform it to say UCSD or Berkeley directory instead. And finally, we have to provide interfaces to local outlets. Local outlets are the things that actually present the apps to our end users. Examples of those are things like a mobile app portal or storefront, as well as something like a learning management system tool library. So ways that people are actually going to interact and get these apps. As far as representing an app goes, we represent an app in what we call a payload, not very original. But a payload carries the identity of the app as a conceptual unit that stays constant even as you update the information about your app. It contains a URI that can change freely from the identity underneath it. A URI does not have to be a web link. It could also be something like a native tool launcher. So if your app store supports native tools, you can actually launch native tools out of CASA as well. It's got a timestamp, of course, because that's just something you need to carry in any sort of these propagating networks. It's got share and propagate flags, where the share flag says that you're willing to share it with your direct peers, and propagate tells your direct peers, the people you actually trust in your web of trust, that you're willing to let them share it further. So you can control how far an app travels, or you can let it go freely. And then we have required and optional attributes, the separation of which allows us to say you must implement something like, you must filter on something like the shibboleth attribute, but I don't really care if you agree with my conception of tags or categories or something like that. Since I know we're tight on time, I'll try to move quickly. is attributes, just drilling down one more level. Attributes are UUID based, which allows us to introduce as attributes in the future, makes the system very extensible. An attribute can be as simple as a Boolean value, or it can be as complex as a multi-layered object. And in doing so, it allows us over time to also add more attributes. So Shibboleth may be the identity provider that we're using in most of higher education today, but I can't make a call on where we're going to be in 5 or 10 years. So this accounts for that change over time, and new attributes can be introduced. Similarly, an attribute can be introduced that completely changes the way that we think of something like ratings. So we might have something simple where you just advertise what apps have been rated at. But a vendor who's running one of these stores that people are pairing with might say that all of their apps are rated 5-star. And so over time, new ratings algorithms may develop. And this sort of an approach is going to take into account that issue as well, allowing the market to select the most effective attributes over time. The attributes are also journaled, which is nice because it allows you to take the original version of information or the information that's been transformed and translated and changed over time. And I see you're going for the thing, so let me see if I can just finish it up. And attributes also allow us to have worldview, where we can actually say, okay, this particular attribute is only important in some professional school context or in a particular accreditation system. And so you can introduce an attribute that most people don't even have to worry about, but in some cases does matter. And so this is just a kind of a diagram that shows what this sort of a system might look like. And actually, even in testing already does. We've got a set of outlets, maybe a mobile tools launcher and a learning management system. They're connected to some engine that's got a set of apps. They're talking over a protocol to some other peer-to-peer systems, each with their own apps that are then talking further. So that's how this sort of a system works. And one last slide, just on where we are today. Right now, we've got a partial working draft of the CASA protocol that's going to make this possible. And we're currently working on a reference implementation so that we can actually realize this. At this point, we've got topology testing and stuff like that all set up, and we're actually working on getting the outlets working. Right now, CASA is a collaboration between UCLA, the IMS Global Learning Consortium, and some higher ed and ed tech partners that are involved to various degrees. But we are always looking for other interested parties in all spaces of education. Our goal with CASA is to go into kind of an alpha by May. And it's on GitHub, of course, because it's all open source. And with that, I'd like to say thank you and ask if there are any questions, if we have time. Yes?
I'm going to bring up the poll results.
Yes, okay, so this is really a metadata sharing protocol at the end of the day. Yeah, so the question was if this is limited to apps or it can be used for other sorts of data. And it can actually be used for other sorts of data. The one thing is we are trying to keep it focused at least around URIs and the attributes that describe a URI. And it's just because of the context we're in. But it could certainly expand out and cover other use cases as well.
Just showing the results of our poll real quick. You can look at them yourself as well.
Are there any other questions? All right. Well, thank you very much.